Yesterday, we took a big step forward. We had talked earlier in the unit about momentum. Then we talked about impulse, the change in momentum. Yesterday, we talked about this big law, a big fundamental physics law called the law of conservation of momentum. Just like the law of conservation of anything else, it says that something can't be created or destroyed. Momentum, in this case, can't be created or destroyed. In other words, momentum is going to stay the same if you have an isolated system. What do we mean by an isolated system? You guys remember that? Yep. Good. No matter or energy in or out. That's the technical definition for an isolated system. But really what an isolated system means is you got no external forces. Okay? You got no forces that are coming in or out of the system. No friction that's causing something to slow down. No air resistance that's causing it to slow down. Nobody pushing it that's causing something to speed up. You got no external forces. If we encompass everything, if we make our system big enough, then there are going to be no external forces. Or, ironically, if we make it small enough, if we look at just before and just after the interaction, we might have no external forces. Bottom line is, if there's no forces other than what's acting within the system, then we can say the law of conservation of momentum applies. In other words, the total momentum before the interaction will be the same as the total momentum after the interaction. What do we mean by an interaction? Well, it's a collision or an explosion. Okay, yesterday we did an example where we had a collision. Two objects collide with each other, hit each other. We can use the law of conservation of momentum. An object explodes. A bomb explodes into a bunch of pieces going everywhere. Okay, a gun is fired. Bullet goes one way, gun goes the other way. Okay. Collision or explosion is an interaction in which we can use the law of conservation of momentum as long as there are no external forces. Finally, we said yesterday that although there can be a change in momentum, momentum always remains the same. What does that mean? There can be a change in momentum, but momentum always remains the same. How is that possible? Isn't that a paradox? There can be a change in momentum, but yet momentum always remains the same. Good. When we're looking at the change in momentum, in other words, the impulse that we've been looking at over the last several days, we're looking at an individual object within the system. Okay, two football players are running towards each other. They collide, they bounce off. If we look at the entire system of both football players immediately before and immediately after that collision, then the total momentum of that system will remain the same. But each of those football players had a change in momentum. One of them gained momentum, one of them lost momentum. The total amount of momentum stays the same, but individuals gain or lose. So if you think back to all those impulse questions, and you might not have noticed this at the time, and that's okay, but if you think back to all those impulse questions we did, every single one of them involved a single object, not a system. Every single one of them involved an object, a rock, a ball, a person gaining or losing momentum, as opposed to what we're doing now, where we're looking at the rock that collides with the car or whatever, right? Looking at the system. Now, strictly speaking, we can use either one. When we see a collision between those two football players, we can analyze both football players at once using conservation of momentum, or we can choose to analyze one at a time using impulse. It doesn't really matter. My suggestion is, normally at least, when you've got a system like that, with a collision involved, or with a collision within that system, then you're probably going to try conservation of momentum first, because it's usually the most efficient way. Okay? But impulse is also available to you if you want to look at one object at a time. All right, so how do we write this down? How do we record, or how do we solve a problem involving conservation of momentum? Well, if momentum stays the same, then PI will equal PF. And you're going to write in for initial momentum and for final momentum an MV term, a momentum term for every object that you have. M1 V1I plus M2 V2I plus M13 M13I, depending upon how many objects you have. M1 V1F plus M2 V2F, and so on, depending upon how many objects you have after the collision takes place. Okay? Count up the number of objects you had before, put an MV term for each of them. Count up the number of objects you have for after, put an MV term for each of them. We have 2 questions for homework last night on page 477. Any issues with either of those 2 questions on 477? Yep, absolutely. Let's do 2 and 1, or if you don't mind, we'll go 1 and 2. Is that okay? So we'll switch the order of it up here, guys. We'll go 1 and 2. All right, so a student on a skateboard with a combined mass of 78.2 kilograms moving it east at 1.6. As he goes by, the student skillfully scoops up a 6.4 kilogram backpack where he left it. What's the velocity of the student with the backpack after he picks it up? That's kind of like a collision, right? He's skateboarding along, he gets his backpack, he scoops it up, just like a car comes along, hits another car, and entangles with the other car. Now, these questions become a little bit confusing as much as anything for the givens, because there's so many givens that we have to write down, Rucker. So many different things that are similar, masses, like different masses, different velocities, sometimes 4 velocities in the same question. We're going to call this M1, the student and the skateboard. Okay, that's one object. We're calling it M1. The backpack we're going to call M2. Now, this velocity right here, what's that going to be? Is that going to be V1 or V2? This 1.6 meters per second, right? That would be V1, right? It's the velocity of the student in the skateboard, V1. But is it V1I or is it V1F? Initial or final? It's initial, V1I. That's it, isn't it? Is there anything else that we have if we read between the lines here, Lewis? VFI, V2I, okay. V2I is 0. Okay, so the velocity of the backpack before the collision is 0 meters per second. It's not moving, it's sitting on the bench, right? Anything else we have? Or anything else that we're looking for here? Is final mass? Yeah, we could find that, but that's not what we're looking for. Okay. Yeah. Yeah, we're looking for the final velocity. Now, I'm not going to call that V1F or V2F. I'm just going to call it VF. How come? Why do I have no number subscript there for that? Go ahead. Right. There's only one object. If you want to call it V12F to remind yourself that it's object 1 and 2 combined, you can go ahead and do that. But there's enough subscripts as far as I'm concerned, enough small number subscripts up here. So I'm just going to leave that off. All right. We know to do PI is equal to PF. And we know that we have to add in an MV term for every object that we have. How many objects do we have before this collision takes place? Janessa, how many do we have before it takes place? 2. There's the skateboard and the student, right? That's one object. And then there's the backpack. So we're going to go M1 V1I plus M2 V2I. How many objects do we have after the collision takes place? Maddie? Just 1. So let's call it MVF. Now, if you want to save yourself a little bit of time and effort in punching numbers into your calculator, we can get rid of one of those terms. Which one can we get rid of? Yeah. In fact, if we wanted to, we could have even avoided writing that down in the first place. All right, M1, we established is 78.2 kilograms. V1I is 1.6 meters per second. What's M? Aiden, what's M? Over here on the right-hand side. Good. 84.6 kilograms. It's the combined mass, right? Because now the kid has the backpack with him. VF. What's your prediction? Is VF going to be bigger or smaller than 1.6? Bigger or smaller? Kelsey, bigger or smaller? You can see the answer there, but pretend you don't see it. Why do you think it would be smaller? Okay, it's logical. Yes, it is logical. But why is it logical? Billy? Go ahead. Okay, so if the momentum here is the same as the momentum here, and the mass is bigger over here, then the velocity's got to be smaller over here, right? And mathematically, we do that on our calculator. We find that, sure enough, it is. Not that much smaller, because the mass isn't actually that much bigger. But it's a bit bigger, so the velocity is going to be a bit smaller. Is that okay? Whoever asked me for number one? Is that you? Did you ask me for number one, Stephanie? Is that okay? So go 78.2 times 1.6, and then divide it by 84.6. All right, let's take a look at number two now. 1,050 kilogram car in an intersection has a velocity of 2.6 to the north. The car hits the rear of a stationary truck. The velocity of the car-truck system afterwards, they stick together, they lock together, 0.78 meters per second. What's the mass of the truck? Oh, good question. Good question. I like this one. Let's call this M1. Let's call the mass of the truck M2, and that's what I'm looking for. Let's call this what? V what? V1 or V2? Dallas, is that V1 or V2? Good, V1I. Good. What's V2I? What's V2I, Braden? Oh, pick the guy who's yawning, sorry. Sorry, I didn't mean to do that. Braden, what's V2I? Yeah, good, because it's stationary, right? The truck is not moving. The velocity of the car-truck system immediately afterwards is 0.78. What's that going to be? V1 or V2 or something else? What is it? VF, yeah. It's not V1 or V2. It's both of them combined. 0.78. Looking for the mass of the truck. So let's say PI equals PF. We're going to say two objects before, M1 V1I plus M2 V2I equals what? Equals what? Jeff? How many objects do we have after they collide and stick together? Right. So we're going to have one term, MVF. Good. M1, 1,050. 2.65. This is 0, right? Same as the last question. Combined mass, oh, wait a second. Wait a second. We don't know the combined mass, do we? Right. Let's do this. Okay, let's leave M there. Okay, solve for M. Final velocity is 0.78. What do you get for that M? I'm not sure what it is, but I'll tell you it's not 2.5 times 10 to the 3. 3,567? Boy, oh boy, oh boy. This is a quiz question. This is a test question. This is a diploma exam question. I guarantee you at least a quarter of you will bubble in that one. 3,567. If this is a multiple choice question, I guarantee it's an option. But why is it wrong? That's it. Yeah, this is the total mass, right? This is the total. We want to find the mass of, that's a bad subscript actually, because that looks like the mass of the truck. The total mass is 3,567. The mass of the truck is 3,567 minus 1,050, which gives me 2,517. Is that right? Which, for two digits, is 2.5 times 10 to the 3 kgs. I like that question. It's a great question to test the basics of conservation of momentum, but also, are you paying attention to what you're being asked for? Hey, sometimes people on a unit test say, oh man, like I could do the homework questions. I got almost all of the homework questions, but then the test questions are hard. Okay, if one of these two questions is going to be on the test, question 1 or 2, which one do you think it would be? 2, right? So if you get 5 out of 6 homework questions, it's probably the 6th homework question that's more like the one that you'd see on a test. Okay, so don't be Don't be comfortable with 5 out of 6. Okay? Be happy with yourself, especially first time around. If you get 5 out of 6, that's good. Okay? But make sure you know how to do that 6th one, because it's not necessarily that one per se is going to appear on the test, but that's the type of thing, right, that appears on tests is the more challenging ones. Okay? Okay, let's do another example here. 9.7. This one's similar, but yet a little bit different here. Let's scratch out this stuff because I shouldn't have even put that in your notes because basically they give us the givens already. Does a basketball player in her wheelchair have a combined mass of 58 kilograms? She moves at 0.6 to the east and pushes off a stationary player. Okay. Once again, the second player isn't moving, just like in the last bunch of questions we did. Player A ends up moving to the west. Oh, wait a second. Picking up the red pen. How come? What is it? Different directions. I got an east and a west here, right? That's the difference between this question and the questions we just did. Everything was in one direction in the questions we just did. Now it's a couple of different directions. So we have to pay attention to negatives now. We didn't before. Combined mass of player B is 85 kilograms. What's player B's velocity? All right. Let's call this M1. We could call it MA if we want, but I don't like that. I don't like MA. MAI, MAF. I'm not an English person. Okay? Letters confuse me. Okay? I go with numbers. M1I, M1F. Okay? If you'd rather go with MA because that's the way it's expressed there, that's fine. Okay? But I'm going to go with M1 and M2. Okay? We got M1, we got M2. This is a velocity. Going to be V1 or V2? Tyler, V1 or V2? Good. Is it V1I or V1F? Good. V1I is 0.6 to the east. Pushes off a stationary player, player B. That means that V2I is going to be 0. Player A, that's player 1. We renamed this girl player 1. 0.20 meters per second. We're going to call that V1, player A, V1I or V1F? Sean, V1I or V1F? This velocity right here, the 0.2 to the west. Nope. Player A ends up moving after the collision. Right, V1F. And I'm going to put a little note here that it's negative. I circled the west in red to remind me. I'm going to just listen. It doesn't hurt to draw attention to it in a million different ways so you don't forget that. We're looking for V2F, right? Okay. PI equals PF. Two objects before the collision, M1 V1I plus M2 V2I equals two objects afterwards, M1 V1F plus M2 V2F. This disappears because V2I is 0. 58 times, I'm going to make a mistake here, okay, on purpose. Not necessarily right now. At some point, before I'm finished the question, I'm going to make a mistake on purpose. Stop me when I do, please. Don't let me go on. Okay, I won't stop myself. Okay, one of you guys is going to stop me when I make that mistake. V1I is 0.60 meters per second. M1, once again, is 58 kilograms. V1F is 0.20 meters per second. All right, look at that. I kind of set that up, right? Negative, right? Good. At least you caught it. Good. M2 is 85 kilograms times V2F. Okay, let's do this on our calculator together here, just to make sure we can do this. It's a little bit trickier than the last set we had done. Let's say 58 times 0.6. Okay, it's 34.8. Now, let's take 58 times 0.2 to the left-hand side by adding, right? Because it's a negative on the right-hand side, it has to come to the left-hand side by adding. Now let's divide that by 85. Gives me 0.54588. Which we should round that to 2 digits, 0.55 meters per second. Or you could say 5.5 times 10 to the minus 1. Good? Is it much different than the two questions that we just did a few minutes ago? Not much different at all. What's the big difference? Positive and negative. If this is a multiple choice question, you can be sure that if you make it negative, if you forget the negative, the answer you get will be one of the options. It'll be a wrong one, but it will be there. Pay attention to these things. Circle these things. Underline them. Highlight them. Don't forget. Okay? And I'm telling you, you might be sitting there thinking, what is he, crazy? I'm not going to forget that. East and west, that's easy. That's easy to remember that one of them is positive, one of them is negative. I'm telling you guys, this will be the 40th diploma exam that I've been through. The 40th Physics 30 diploma exam that I've been through. Thank you. I promise you, I know what mistakes people make. And I promise you that that's one of them. I will give you a written response test down the road. And that written response test, I'm telling you right now what that test is. There's a collision. Part of the test is, at least, there's a collision. You have to calculate, Cassidy, I believe it's the final velocity. One of the objects is going to the north. One of the objects is going to the south. 75% of you will get that question right, that part of the question right. 25% of you will forget to make the one that's to the south a negative. Okay, that's a quarter of you. Will still make that mistake even after I'm saying this. A quarter of you will still make that mistake. Don't be that quarter. Don't be that person. Okay, pay attention and don't be in that quarter. Yeah. All right. A couple of questions on page 478. We'll give you a few minutes to work on that right now.